Our next unit is going to be on thermochemistry. Thermo, of course, means heat. Chemistry is chemistry. So we're going to be talking about heat. A couple terms you're going to need to know. Endothermic and exothermic. Endothermic means the system is absorbing energy. Exothermic means the system is releasing energy. So something that absorbs energy is going to get warmer, and it's going to remove energy from the surroundings. You put a piece of ice in your hand. That piece of ice is going to remove heat from your hand. So the ice is getting warmer, but your hand will get colder. Okay, this heat always goes from an area of something heating to something cooling. Whereas if you have boiling water and you put boiling water in the palm of your hand, the heat will go from the water into the cells of your hand, and that water will begin to cool, but your hand will feel the heat. Okay? Endothermic heat goes in, exothermic heat comes out. Okay? Temperature is basically proportional to the average kinetic energy, which we talked about a little bit with gases. We know the faster a gas moves, the higher the temperature. So really what you're measuring is the average kinetic energy, and kinetic energy can be defined as 1/2 times the mass times the velocity squared. So you're talking about how fast the molecules are moving. As the temperature increases, molecules are going to move faster. As it decreases, they're going to move slower. So, therefore, our definition of heat is the flow of energy, and enthalpy takes into account both internal energy, pressure, and volume. For most circumstances, enthalpy and heat are going to be the same. Now, we're going to talk about heat this week, and then we'll get into enthalpy next week, because we're going to be talking about breaking bonds and the kind of the more minute things. This week, we're just going to do calorimetry and heat transfer that way. Okay? You may have done in middle school or even in elementary school a discussion of temperature change, of heat transfer. 3 basic types of heat transfer. There's conduction, which means you're in touch. Heat transfers by touch. There's convection. Some of you may have a convection oven at home. That is heat. Oops. Really don't know what I did there. Jeff even followed me home. Heat transfer by moving fluids. And I have to define fluids. A fluid is a liquid or a gas. So, as gases change and move, or liquids, as they heat up, they change shape. A solid doesn't change shape as you heat. Well, it changes shape, but it's not enough. But you get different densities with the fluids as you heat them and cool them. Your house is heated through convection. In the winter, because heat rises, because the molecules move faster, hit each other harder, spread out, kinetic theory of matter, they spread out, take up more space, therefore they're less dense. Heat rises. So in our house, we shut off all the vents upstairs and force all the air downstairs. That way, that heat rises. In the summer, we do the opposite. We force all the cold air upstairs, and that cold air sinks. That's why the attic is often the hottest place in the house, and the basement's often the coldest place. Okay, that's convection. A convection oven is just moving air around in the oven, as opposed to a regular oven, which is just heating the air. Okay? Not ever used a convection oven, but that's what it is. The third kind is radiation. Radiation is heat transfer through space. When you walk outside and you feel the warm sun on your face, that's radiation. When you walk outside and you can feel the heat radiating off the sidewalk, that's convection. And if you're barefoot, standing on that hot sidewalk, and your feet are burning, that's conduction. So anytime you want to keep things from heating, where did my mouse go? Come on, mouse. Anytime you want to keep things from heating, what you'll want to do is find a way to stop conduction, convection, and radiation. A thermos does that very effectively. The most common energy units that we're going to come in contact with are joules and calories. Interestingly enough, hold on for a minute. Here is a food label for a Symphony chocolate bar, and you can see on their label energy is in both kilojoules and kilocalories. Okay, we're used to using calories. When we talk about food calories, we're really talking about a kilocalorie. A food calorie is 1,000 of a regular calorie. A kilojoule is the same story. So if you were to go overseas, somewhere that the world is mostly metric, you're probably going to get your energy values in kilojoules. We're going to try to stick to kilojoules. We're not going to switch back and forth. Okay? All right. Back to the PowerPoint. 1 kilocal, it's important to know, 1 joule is equal to 1 calorie is equal to 4.184 joules. So if you do get something, you can make that conversion. Heat capacity. Stop and think for a moment about what happens when you heat different things up. Some substances heat up very, very fast. If you've ever left a metal spoon in the pan on the stove, the metal spoon heats up very fast, but a wooden spoon does not. If you have a cast iron skillet, you have to use a handle with it. If you have you have to use a hot mitt with it. Whereas if you have a conventional skillet, a lot of them have like a wooden handle or a plastic handle that's not going to conduct the heat as well. Okay? So, what something is made of affects how much it heats up. We call that heat capacity. Heat capacity is the amount of energy it takes to change a gram of substance by 1 degree Celsius. Okay? That's the definition of calorie. 1 calorie is the amount of energy it takes to change 1 gram of a substance by 1 degree Celsius. So therefore, 4.18 joules is the amount of energy it takes to change 1 gram 1 degree Celsius. So we get this kind of funky little unit there. Okay? Heat capacity is different for different things. Metals are a great example of different heat capacities. A high heat capacity means it's going to take a lot of energy to change. So it's going to heat up slowly and cool down slowly. A low heat capacity means that it will change very, very quickly. Okay? You'll notice water, I said the heat capacity of water is 4.18, which is the same definition as 1 calorie. Okay, mouse, where are you? Back in the day, when I taught junior high, we would talk about land breezes and sea breezes. And we would talk about if you were living on an island, and here you are, okay, and the ocean's out here. During the day, the land heats up very fast. So as the land heats up, because it has a low heat capacity, the air over it's going to heat, it's going to become less dense, and it's going to rise. This creates low pressure. Nature hates low pressure, so it's going to send air in from over the ocean, and it provides a nice cooling breeze for you when you're standing on the edge of the ocean. Okay? So you can lay out, get a suntan, do whatever it is you're doing, and you're going to have a nice cool breeze, almost guaranteed. At sundown, the water now has been heating all day. It has a very high heat capacity, so it's now going to cool off very slowly. So now the water is warm, but the land cooled off. So the water is now warmer than the land, so the water is going to be heating the air around it more than the land, and the air is going to blow out to the ocean. This is what we call a land breeze. So at night on the edge of the ocean, you've got your wind blowing towards the ocean off the land. It's going to keep you warmer. Okay? That's a perfect example of heat capacity. Water has a high heat capacity. Land has a low heat capacity. Okay? I just drew that. So, the other thing that can affect heat is the mass of a sample. The bigger the mass, the more molecules there are for it to heat up. Back to boiling water. If I have a cup of boiling water and a dropper of boiling water, which are you going to let me put on your hand? You're going to let me put one drop. Well, you're not going to let me put either on. But if I'm going to, you'd rather have just one drop versus a whole cup. Because one drop of water, even though the temperature of that water is very high, because if it's boiling water, it's 100 degrees Celsius, that one drop doesn't hold as much heat as that cup would. In fact, sometimes you can get into situations where something that's cold, we would consider cold, that has a lower temperature, actually will have more heat than something we would consider hot, because you have to take into consideration the mass. You have to take into consideration what it's made of, the specific heat, and then you also have to take into consideration how much temperature change are you going to have. If you're talking about temperature, change in temperature is always calculated final temperature minus initial temperature. If a temperature increases, a change in temperature, and that little delta, remember, means change, that triangle, change in temperature will be positive. If the temperature decreases, the change in temperature will be negative. Okay? So, that is the basics of what we need to know for calorimetry. We're going to be doing a lab on Wednesday or Thursday, depending on who you are, in calorimetry.